Hello guys, welcome to my video. My name is Anshu Ultramanj and in this video we will talk about rectifiers. We'll talk about what is rectification, how types of rectifiers, half-wave rectifier, full-wave rectifier, and its importance in our daily life. So what is rectification? We will go with the very basic concept of rectification. So it is the conversion of alternating current AC to direct current DC. This involves a device that only allows one-way flow of electrons or current, you can say. Here in this diagram given below, we can see a sinusoidal waveform and how it is rectified in half as well as full wave. In half wave, we can see the of the positive cycle of the sinusoidal waveform is only coming as output, whereas in the full wave, you can see the positive as well as the negative half of the sinusoidal waveform is coming as output. So, how does a rectifier work? The rectifier works with the help of a device called diode. So, what is a diode and how does it help? So, a diode is a semiconductor device that allows the current to flow in only one direction, providing a way to control the flow of electrical current. I'll show you a simulation on how a diode works. So, in this simulation, as we can see, we have a battery whose terminal is connected to the P side of a diode, and here we have a LED. So, when our diode's P side is connected to the positive side of a battery terminal. It is in the forward bias. So what happens in a forward bias? So a forward bias acts as a closed circuit, resulting in the flow of electrons or current, you can say. But when a diode is in reverse bias, it acts like an open circuit. I'll run the simulation and show you how this actually works. So as you can see, the positive side of battery terminal is connected to the P side, and the flow of electrons is normally going all over the circuit and the diode and the LED is on. But when we swap the terminals, you can see the circuit is in reverse bias and the flow of electrons is restricted, hence resulting in which results that the I'll run the simulation and show you how this actually works. As you can see, um, the positive side of the battery is connected to the P side and hence resulting in the forward bias. This results in the flow of current all over the circuit, resulting in the LED to turn on. But when we swap the terminals, this results in reverse bias, as the circuit is acting like an open circuit. So therefore, this LED is turned off. I'll go back to the PPT and show you more on this topic. So what is a half-wave rectifier? So a half-wave rectifier is in half-wave rectification. A single diode is used to rectify the AC. During the positive half of the AC form, the diode is forward biased, allowing the current to pass through. During the negative half of the cycle, the diode is in reverse bias and blocks the current, resulting in a pulsated DC output. This process only allows half of the AC waveform to pass through, effectively clipping off the negative half. I'll show you the simulation on how half-wave rectifier works. So here, as we can see, we have a AC input source and a diode and a load resistor. So I'll run this and show you. So as you can see on the left hand side, we have the sinusoidal waveform, or you can see the AC input voltage signal. And on the right side, we have the output. As you can see, there are gaps in between the waveforms created or formed, you can say. These gaps are the negative half cycle, which are not coming as an output, as the half wave rectifier only rectifies one positive half of the input signal. And there is also some decrease in the size of the waveform. This happens due to the potential barrier which is there in the diode. So let's jump back to the PPT. So we'll talk about VRMS. So what is VRMS? VRMS is volts root mean square. So VRMS is a way to measure the effective or equivalent value of an AC voltage. It is the square root of the average or the square's instantaneous voltage values during one cycle. Purpose: PRMS gives the equivalent DC voltage that would produce the same power dissipation in resistive load. It is commonly used in AC circuits to understand power how much power the voltage would deliver. Ripple factor. The ripple factor of half-wave rectifier. Ripple factor determines how well our half-wave rectifier can convert AC voltage to DC voltage. Ripple factor can be quantified using the following formula. So this is a symbol for the ripple factor, which is equal to the root of Vrms and by VDC whole square minus 1. The ripple factor of half-wave rectifier is 1.21. Efficiency of half-wave rectifier. The efficiency of half-wave rectifier is the ratio of output DC power to the input AC power. The efficiency formula for a half-wave rectifier is given below. You can see the P, it is equal to PDC by PAC. RMS value of half-wave rectifier. The RMS value of the load current of half-wave rectifier is given by the formula given below. As you can say, IRMS is equal to IM by 2. IM here is the maximum current which can flow through the circuit. What is the form factor of half-wave rectifier? The form factor is the ratio between RMS value and the average value and is given by the formula. Form factor is equal to RMS value by average value. Form factor of half-wave rectifier is 1.57. So what is full wave rectifier? So in full wave rectification, two or more diodes are arranged in bridge configuration are used. The AC waveform is split into two halves, and each diode conducts during the respective half cycle, allowing both half of the AC to be utilized, but in a unidirectional manner. The output is smoother compared to the half wave rectification, providing a higher average DC voltage. I'll show you how a full wave rectifier works. So here we have a simulation and a circuit of full wave rectifier, a AC input signal, four diodes which are connected in the bridge form, and a load resistor. Load resistor. So here, as you can see, the green lines represent the AC voltage or AC signal, and the red lines represent the output wave signal. You can see positive as well as the negative half of the input waveform are rectified in this rectification. So here we can see there is also some slight decrease in the output waveform. The size of the amplitude, or you can say, is decreased here. This happens due to the potential barrier of each diode, which are contributing in the circuit. Now we'll go back to the PPT. So what is the ripple factor of full wave rectifier? The ripple factor determines how well a full wave rectifier can convert AC voltage to DC voltage. Ripple factor is same as which was for the formula for ripple factor is the same as half wave rectifier. It is under root Vrms by VDC whole square minus 1. Efficiency of full wave rectifier. The efficiency of full wave rectifier is the ratio of output DC power to the input AC power. You can see the formula is also same for full wave rectifier as it was for the half wave. It is PDC by PAC. RMS value for full wave rectifier. RMS value for the full wave rectifier is equal to I max by root 2. For the half wave rectifier, it was I max by 2. Form factor of full wave rectifier. The formula is same, but the form factor of full wave rectifier is 1.11. So, what is the importance of rectifier in our daily life? Smartphone and laptops they require DC power to charge and operate. The power electrical grid provides AC. Rectifiers inside chargers convert AC into DC, hence resulting in charging of battery, which is charged by DC power. LEDs also need DC power to function. The rectifier inside their power supply ensure the AC from the grid is converted into usable DC for the LEDs. TV and other electronics like laptops, many consumer electronics have AC to DC converters inside them to power internal circuits. So, in summary, rectifiers are a crucial device which helps in converting AC power grid to DC, which powers various devices and ensure they function properly. Thank you for watching this video. Hope you have a good day ahead.